I love the beginning of a live when there's no one here and you're just like talking to yourself. But hello. I just finished making myself some coffee. Yum. So normally I do videos on Mondays, y'all know. But I'm working on a video right now and it's been a pain. It's just not coming together the way I want. Anyway, so it's not ready yet. But I didn't want to like not do anything because I didn't do anything last week because I was still struggling with this video at that point. So I thought I would go live, and since lives can be a little weird, I find lives to be weird. I like to give myself something to do. So I thought I would talk to you guys about some books because I get asked this a lot. People ask what books I would recommend. And I don't really have books I would necessarily recommend because I don't think I know enough about like all of the books that are out there. And also because I am like trained and educated in physics and in, astronomy and stuff, like I don't always enjoy like the pop sci books just because they're not the right level for me. And so I don't know that I can like really make a great like unbiased review of them. But what I do have is all the books that I have used over the years or ones that I have got and read. So I will show this to you. Okay, this is, oh, you can't quite see it. There's a whole stack here. Oh my God. Okay, this is really heavy. Oh boy. Okay. All right. So, first things first, these two books are a set, Volume 1 and Volume 2. And these are by Tipler and Mosca. And these were my textbooks for my very first, so I was a physics major in undergrad. And in my undergrad, we had to declare our majors at the end of freshman year. So freshman year, we didn't take any major classes. And then sophomore year, we started taking them. So sophomore year, I had to take, like Physics 1 and Physics 2. And these were the books we used. And I found these to be pretty good. And then when I was getting ready to go back to grad school, and it had been, 8 years since I had studied physics, and I kind of needed to reacquaint myself with some of the topics, I used Tipler and Mosca, and I found them actually to be pretty helpful. So yeah, these ones I have. Volume 1 is Mechanics, Oscillations and Waves, and Thermodynamics. And Volume 2 is E&M, Electricity and Magnetism, Light and Modern Physics. Okay. Ooh. All right. I didn't keep all of my books from undergrad, like all my textbooks. Those ones I did because they were like good introductory level for just like all of these things. But another one that I did keep from undergrad, sort of dusty. I don't necessarily look at these all the time. Was this one, which is of course at the bottom of my stack here. Sorry, just hit my microphone. Apologies. This doozy of a book. This is like one of my go-to books. When you like need a heavy book for something, like, oh, I'm gonna like press down the edge of this thing. That's good. This is my go-to. This is called Mathematical Methods. Oops, that's upside down. Mathematical Methods for Physics and Engineering. Second edition. And this was not like, so I feel like with the Tipler and Mosca books that I was just showing, like, those have like chapters and we would be like, we're doing a unit and that's this chapter. This is a bit more like a reference book. Like you need to learn a method, you can look it up in here. It's not like we would necessarily be like, we're going to do this chapter today. The class that I used this for was a math class. So it was a 2-semester long series and I had 2 different professors for it. And the first professor did not use a textbook because he had actually written his own material over the years. And so, but it wasn't like an official textbook. It was just like PDF files that he would like send us. He was like, I don't know. I mean, I was like 19 at the time. So he seemed very old to me. But I'm not sure how old he actually was. But his name was Tankersley. And so we called him Tank Professor Tank. But then we also had a younger professor who started kind of taking over the course, and he actually had a textbook for us to use. And I kept this one because it is a good reference. I think a lot of the stuff that I did with this, because this was basically like after, I took like calc up through calc 3, I took DFQs. That was like, so this was like after this. This was a lot of linear algebra stuff that we did in here, like a lot of matrices, that kind of stuff. But I'm sure it has probably almost everything you could think of in here. So there you go. And it's fun. Okay. And then I have 2 more from undergrad. This one is called Non-Classical Physics. So in the Tipler and Mosca, the volume 2 has a section called Modern Physics, which is a bit of a misnomer. So modern physics basically refers to like 1920s and beyond, basically like the discovery of quantum mechanics and kind of atomic physics and stuff like that. Which is not so modern anymore. It's like a century ago. But this one is the same subject, but it's just called non-classical physics. So this was for my, I'm trying to remember what my actual course was called. Was it called Modern Physics? It might have been called Physics of the Atom. But yeah, so this has a lot of quantum stuff in it. Special relativity, stuff like that. Oh, there was StatMech in this too. I don't think we used the StatMech section, but oh my gosh. So cute. If you guys don't believe me that these are for my undergrad, look at this title page here where I wrote my name and this number. So I went to the Naval Academy for my undergrad, and so we were assigned a number on our first day, and we had to use that number for like everything. Like our email address was that number, and that was mine, 0900342. It was alphabetical, so that's why mine was so 09 was my class year, and then 0342 was alphabetical. All right, and then okay, so those are all of my physics ones. Then for me, for my undergrad, like physics was the major, but we could pick a track within that. So there was a nuclear physics track. There was another one that I can't even remember what it was. And then there was an astrophysics track. And obviously I did the astrophysics track, because why not? And so I had to take some astrophysics courses. And for that we used this book, which is Carolyn Ostley, An Introduction to Modern Astrophysics. But what we actually called this was Bob. And that stood for Big Orange Book, as you might guess. And actually, orange is my favorite color, so I was very keen on this. I wonder if this also has my alpha number in it. Okay. So this is an excellent book. I, to this day, still use this. Like when I am working on a video or a topic that I want to like cover, I usually start here. It's just a great like introductory reference. It has so much stuff in it. Obviously, look how big it is. My only complaint with this is that, I graduated undergrad in 2009, and like this was already a little bit old by then. So now it's a little out of date. I'm trying to find the year on it. (2007). Oh, this must have just come out then. This edition. This is the second edition. This edition must have just come out because 2007 was the year I was taking that class. Okay, so it was brand new, I guess, when I was using it. But now it's a little bit out of date. And if you're thinking, how much has astrophysics changed in 10 years? I mean, a little. Like, things are always happening. I think maybe it's especially noticeable for me because my field is exoplanets, and exoplanets has changed so much. So this book was before Kepler launched. There's not even that much material about exoplanets in here. In my undergrad astrophysics course, we spent literally like one day talking about exoplanets. It was like they kind of were a thing, but not really. So yeah, this doesn't have a ton of exoplanets information. And I'm sure there's other stuff in here, like if I was more familiar with other subfields, I would probably have similar complaints, but I think for just general background, this one is really great. So this one I actually do recommend. I think the other ones were ones, that I just used because my professors got them for me. And I mean, this one is also one I only got because a professor picked it out. But as far as I know, this is kind of one of the best, overview introductory texts for astronomy and astrophysics. I hope they make a 3rd edition soon. I wonder if they're planning to do that. Okay. Whew. So those are all my books, my textbooks from undergrad that I kept. Like I said, I had other ones that I got rid of because I didn't think they were going to be all that useful. All right. What next? Okay, so then I went through a period of time where I was not in school and I was not planning to go back to school, but I was still very interested in astrophysics. And so that was kind of the period where I think I read more of the like pop science type books. And I had a couple that I didn't keep. I got a couple as like gifts that were like, I think I ended up not keeping them. I also, I lost a lot of belongings in a fire about, 6.5 years ago. Yeah, there was a fire in my moving truck. So a lot of my things were damaged, and so I lost some books in that as well. So I don't have all of the books that I ever had, but I do have this one. And I think I might have got this one during undergrad, but not as a textbook, just for fun. And this is The Planets by David Sobel. And I knew David Sobel because she, I was like, I don't even know her gender. She wrote a book called Longitude, which was actually, I think, like extra credit reading for one of my naval courses, because the development of longitude is hugely important for navigation on the oceans. Anyway, so I had read Longitude and really enjoyed it. And then I think I saw this and I either asked for it for a present or I bought it myself. I'm not sure. But anyway, it goes through all the planets of the solar system. It's a cute little paperback. Like, look at this. Okay, there's like a hole in the camera. And then you're like, oh, I really like that. And it just goes through all the planets. And I haven't read this in years, to be honest, but I remember really, really liking it. And kind of, for me, confirmed that what I was most interested in was exoplanets. Now, this is not exoplanets, this is planets in the solar system, but there's so much overlap between planetary science and exoplanet science. It's a very multidisciplinary. There are some, like, depending on what school you're in, exoplanet studies might be in the like earth science, planetary science department, or the astro department, or both. So anyway, so I actually do highly recommend this one, although I'm guessing it's a little bit out of date because, let's see, this is from 2006. This is actually in very good condition considering I've owned it for like 15 years. God, this is making me feel really old. Oh boy. 2006 doesn't seem that long ago to me. What can you do? Okay, so yeah, this one is great. Actually, I kind of want to reread this now. I totally have time. And then another one I got that is, so that one is very much like meant to, I think, be like kind of just written narrative, like pop sci book. This was one I bought that I bought for fun. I think at a used bookstore, but is more on the kind of textbooky side. Adventures in Celestial Mechanics. Somehow, even though I bought this book for fun before I even was planning to go back to grad school, I didn't really realize that I wanted to study dynamics. Like, girl, this was on your bedside table. Obviously, I should have known that was what I wanted to study, but I really didn't. This book is by a person whose name I cannot pronounce. I apologize to Victor Shebeheli. I don't know. But anyway, it's called Adventures in Celestial Mechanics, a first course in the theory of orbits. I actually did not finish this book because it got very technical and I wanted to my plan was to finish it and to actually like work out some of the exercises because like I said, it's kind of like a textbook. So there's like exercises at the end of the chapters and stuff. And then I think when I was part of the way through it was when I decided I was actually going to go back to grad school. And then I was distracted by doing things like studying for the physics GRE. And then, eventually I didn't really have time to be working on this in my free time since I was doing my PhD in the same subject. But this is, I think, great if you are really interested in the math, which I am. I know not everybody is. Not everybody's keen on math, but I think it's a lot of fun. And I found it to be, a good introduction, although definitely a little bit overwhelming. So I wouldn't necessarily say this is a great, casual read, but if you are very interested in these topics, I think this is a good introduction. And there was like a little cool history chapter in here too, if I recall. Because one of the things I think is so cool about celestial mechanics is that one is something that we still are researching and there's still so much more to learn, and yet it has such a long history. So like obviously you can go back to Kepler, Newton, and a lot of people since then. So anyway, I still have this book. I don't know that I will ever use it again, but to me, I keep it because it kind of represents the period of my life in which I was finding my way into realizing I wanted to get my PhD in astrophysics, and because I think it's funny that I seriously went into my PhD being like, I don't know what subfield I want to study within exoplanets when I had this book on my night table. I'm a dum-dum. Okay, speaking of preparing for my PhD, oh, actually, no, that's not true. I did have one more pop sci book that I still have, and the only reason I still have it is because it's on Kindle. Otherwise, I probably would have gotten rid of it. My Kindle. Oh, I forgot I have my Exoplanet Watch sticker on my Kindle. That's so cool. This is a citizen science project that is very cool if you're interested in exoplanets. Okay. This book, sorry, it's not really easy to see on a Kindle, but it's called Knocking on Heaven's Door, How Physics and Scientific Thinking Illuminate the Universe. And oh my God, this title is so long. Anyway, the main title is Knocking on Heaven's Door. And it's by a physicist named Lisa Randall. And I started reading this, and I'm not going to lie to you guys, I did not finish it. Nothing against it, and I think that it could be really interesting to read. But I think this was one of the biggest examples for me of reading a book that was just not the right level for me to enjoy. If I recall correctly, it was a lot about particle physics and, like the Standard Model and like gliders and stuff. So not only, you guys know that if you're here, you probably know that I have a PhD in astrophysics. And I did my undergrad in physics. And so that's usually, what I talk about when I talk about my education. But I was in the Navy, and I was a nuclear officer in the Navy. So I did a year of, I feel like I'm all over the place here. Okay, but I had to do a year of training, which was 6 months of classroom-based theoretical training, and then 6 months of practical hands-on operating a nuclear reactor experience. So during that 6 months of classroom training, this was at the Navy Nuclear Power School. It was basically my job to learn about nuclear theory, nuclear engineering, how a reactor works, and all the physics behind how a reactor works. So I am very familiar with that area, even though it is not really super directly related to what I do now, and it's not something I talk about a lot. Also, all my training was classified, so I can't really go into too much details about it. But yes, so I am very familiar with nuclear physics, even though it is not my main area of interest. Okay, and then that brings me to this book, Conquering the Physics GRE. So when I decided I wanted to go back to grad school, obviously I was like, okay, I have to do the GRE and I have to do the physics GRE. Now, a lot of astronomy departments have been dropping the physics GRE requirement. So if you are yourself interested in going to grad school, you may or may not actually need to take the physics GRE. But at the time, it was pretty much required. And because this was in 2016. So this is, I believe they've done a new edition of this, but this is by Kahn and Anderson. And this was so helpful. This book was amazing. At the time I was going through Tipler and Mosca to kind of reacquaint myself with physics concepts in general. And I was using this. I would go through every chapter and make note cards. I actually have my old YouTube channel. I say old. I do still occasionally post up on it. My personal YouTube channel. Where before I started this channel, I would occasionally do like SciComm-ish videos. And one of the things I did was show off my note cards for my physics jury because I had a video talking about the physics jury that was my most popular video. Anyway, so yeah, I highly recommend if you are prepping for the physics jury, this book in whatever its newest version is. I found it extremely helpful and I did fine on the physics jury. I wouldn't say I did great. Although I was like kind of disappointed in how I did in the physics jury, but then I was like talking to someone else and they're like, no, that was actually pretty good. So I don't know. I have a very skewed perspective of these things. But anyway, great book. I don't know why I still have it though. I'm never going to need to take the physics jury again. I should probably get rid of that. Okay, and so then that brings me to books I got in grad school, which is actually not that many because I would say most of grad school was not learning from textbooks. It was learning from papers, which makes sense. But I did get one very, very important book. Actually, no, we're going to end on that book. We'll go with this one. So this book is called Searching for the Oldest Stars by Anna Friebel. She's a professor at MIT. She's really nice. I met her once. This is, I would say, like a pop sci book. It's like, I think, meant to be read by the public, but was actually used, and the reason I own it was it was used as a textbook for a course that I was TAing, which is the teaching assistant. So I was a teaching assistant for this course. So the professor gave me a copy of the book. Maybe I was supposed to give it back. I don't know. He never asked for it back. I didn't really intentionally keep it or not keep it. I guess it was on my desk for years. And then when I packed up my office, I packed it up. So Dan, if you want this back, let me know. But yeah, so it is, I think, you could just pick it up and read it, but it also does get a little bit into the technical stuff. So yeah, it's not a textbook though. There's no problems, there's no questions. But I think it is a very good introduction to stellar astronomy. So this course that I was taking was a course on stars. So yeah, so even though the subject here in particular is searching for the oldest stars, so what Dr. Frebel does is a field called stellar archaeology, I think. Basically, by looking for these very, very old stars, you can kind of figure out what has happened over time in our galaxy. And so that's the focus. But in order to understand why that's important and how that works, there's a lot of background stellar astronomy that you need to know. So I think this was pretty good. I did not read the entire thing, so I cannot say that I that I fully read it, but it was good, and I have it. Okay, and that does bring me to the last book that I wanted to show y'all today. Coffee. I'm going to the gym after this, which is why I look like this. Sorry, no, this is not my best self here. This beautiful, beautiful book. So technically this book is called Solar System Dynamics, but I just call it Murray and Dermott. So as I said before, my subfield within my subfield, I studied astrophysics or astronomy, whatever you want to call it. And my subfield within that is exoplanets. But then within exoplanets, you can have more further additional subfields. And mine was dynamics, which we saw made sense since I was interested in celestial mechanics. So hence this book, Dynamics. And this is, I would say, a very key reference text for the field of dynamics. It is very recognizable with this blue and orange cover. I think there's other versions that aren't blue and orange, but I've definitely spotted this on people's shelves, in Zoom calls, or you see being I see you got a Murray and Dermott over there. And this is a textbook, so it does have problems at the end of every chapter. It is also very heavily math-based, as much of dynamics is, and goes just into so many different topics in this book. So kind of starts out with basic orbits and goes everywhere from there. One thing that's very interesting about this book is that it is solar system dynamics, whereas I said I studied exoplanet dynamics. So many of the topics in this are very, very applicable to exoplanets. However, our solar system is very nice and well behaved and generally has low eccentricities and low inclinations. So a lot of the approximations that are used in here, because remember, we have to approximate. We literally cannot do the math. It's physically impossible to do math exactly for the three-body problem. So we have to approximate in various ways. And so a lot of the approximations here are like, say, like low E or low I, or kind of very specific to like asteroids. That asteroids, might have high E or high I, but then with the planet, that doesn't. So actually, I did have an entire paper, one of my grad school papers, where I basically took a concept that they developed in Murray and Dermott, but they developed it in a kind of low, they developed it in a solar system type context. And one of the things that I showed in this paper was that approximation actually very quickly became bad for exoplanet systems because, oh boy, I feel like I'm really going into the rabbit hole here. So there's a term called alpha. And alpha in this context is it's a ratio of semi-major axes. So it's always less than 1. So it's the inner semi-major axis over the outer semi-major axis. And in the solar system, alpha is frequently quite low. But there's some terms that depend on alpha that you can kind of safely ignore. But in exoplanet systems, especially Kepler-like systems, alpha tends to be quite high. These systems are very closely packed together. And so if you're interested in the long-term dynamics, which is something we call secular dynamics of the systems, then you really need to be taking into account all these extra terms. And so I showed that in this paper and used the approximation that they developed in Murray and Dermott and actually figured out which terms needed to be included. And it ended up being like a 3-page long equation. That's one of the things I just love about dynamics. You wouldn't think it was that complicated, but it is. Anyway, so this is an amazing book and I love it. And I still reference it basically anytime I have a question about dynamics. This is my go-to. What did Murray and Dermott have to say about it? So if you are interested in dynamics, again, this is a book I would recommend, but also it is a textbook and it is very, complex. This is not like a casual read. So yeah, I think those are all the nonfiction physics and astronomy books that I have. I don't know. That was all I had to show you guys today. How's everyone's day going? Oh, I'm so bad at doing lives. I feel so weird, like I'm just talking to myself. I mean, I guess we can just cut it off here. Yeah. Bob is the best. Bob is so good. Buying books in grad school was not really. I bought one book. I actually regret that I bought this book too. So I bought a book for a required course I had to take on the interstellar medium, and our instructor recommended a textbook. And so I bought this book. I bought it new, so it was like $150 or something. And keep in mind that my university did a quarter system. So the classes were 10 weeks long. It's not that long of a time. So I literally needed this book for 10 weeks. I didn't even end up really needing it. I really could have gotten by without it. And then I tried to sell it when I was done because I was like, well, I don't need this. I'm really never going to study the interstellar medium. Not my favorite subject. Definitely not. A different professor once called it the interstellar tedium, and yes, I agree with that. It's just not my thing. But so I tried to sell it, and I found someone that wanted to buy it, and I shipped it to them, and the USPS lost it. They lost my package, and so I was out all of that money. And yeah, that was not a good experience. So definitely, I think within grad school, I didn't really need many books, and pretty much everything was done via papers, or we did take one class where our professor just told us to download the book if we wanted it. He said we didn't need it, but if we wanted it, we could just download it. So yeah, I've been doing space news, but I've not been doing it every week because that was just a little too much to keep up with. But I'm doing it monthly. So actually, next Monday will be the. Sorry, I don't know if you guys can hear that. Like a plane or something. I don't think planes are supposed to go that close to where I live. Mildly alarming. But yeah, so next Monday will actually be the news video for the month of May. So we'll catch up on some of the main news topics that happened in this past month. But yeah, it's just a little too much to do every week for me right now. Okay, I have reached the end of my coffee. You think I'm lying? I prove it to you. But this was fun. Thanks for joining me. And hopefully, this video that I'm working on, which I will give you a little tip since y'all were so nice to stay around for my live, is going to be on the Oort cloud and is going to get pretty heavily into dynamics. So stay tuned for that. But that will actually be in 2 weeks because next week is going to be the space and astronomy news video for May. Thank you all so much for joining me. Yeah, this has been fun. I hope you have the best Memorial Day. Enjoy the start of summer. It is like 60 degrees and cloudy here. So, but I am going to go enjoy myself. Well, I'm going to go to the gym and then I'm going to just relax. Okay. Have a good day. Bye.